Aluminum cans are one of the most common objects in modern life. They hold drinks, preserve freshness, and travel across the world every single day. Despite their simple appearance, aluminum cans are the result of a highly advanced industrial process that combines raw materials, extreme heat, precision machinery, and automation. In this video, we take a closer look at how aluminum cans are made, from raw aluminum to the finished product. By breaking the process into clear steps, we can better understand how modern manufacturing turns simple metal into one of the most efficient and recyclable containers ever created. Aluminum is one of the most widely used metals in the modern world, even though it is rarely noticed in everyday life. It is lightweight, strong, and highly resistant to corrosion, which makes it ideal for packaging, construction, transportation, and industrial use. Unlike iron or steel, aluminum does not rust when exposed to air or moisture. Instead, it forms a thin, protective oxide layer on its surface, which prevents further corrosion. This natural protection allows aluminum products to last for a long time, even in demanding environments. Another important characteristic of aluminum is its flexibility. The metal can be rolled into extremely thin sheets without breaking, while still maintaining structural strength. This property is essential for aluminum cans, which must be light enough for mass transportation, but strong enough to hold pressurized beverages. Aluminum is also an excellent conductor of heat and electricity. This makes it useful not only in packaging, but also in power systems, electronics, and industrial machinery. Because of these properties, aluminum plays a key role in modern infrastructure and manufacturing. One of the most significant advantages of aluminum is its recyclability. Aluminum can be recycled almost indefinitely without losing its original quality. Recycling aluminum requires only a fraction of the energy needed to produce new metal from raw materials. For this reason, aluminum cans are often considered one of the most sustainable forms of packaging. A recycled can can return to store shelves in a matter of weeks, creating a continuous material cycle that reduces waste and energy consumption. This combination of strength, flexibility, and sustainability is what makes aluminum the perfect material for high-speed, large-scale production. The production of aluminum cans begins with raw aluminum material, or recycled aluminum collected from previous products. In modern manufacturing, recycling plays a central role, as aluminum can be reused repeatedly without losing its essential properties. This makes recycled aluminum one of the most valuable resources in industrial production. Before the metal can be processed, it must be carefully sorted and prepared. Recycled aluminum is separated from other materials, cleaned and inspected to remove coatings, labels, and contaminants. This step is crucial because impurities can weaken the metal or interfere with later forming processes. Once the material is prepared, it is transported into large industrial melting furnaces. Inside these furnaces, temperatures rise to more than 600 degrees Celsius, causing the aluminum to transition into a molten state. At this stage, the metal becomes highly fluid and can be precisely controlled. The melting process is continuously monitored using sensors and automated systems. Engineers carefully regulate temperature, chemical composition, and flow behavior to ensure the molten aluminum remains uniform. Small adjustments are made in real time to maintain consistency across large production volumes. During melting, additional alloying elements may be introduced in controlled amounts. These elements help fine-tune the strength, flexibility, and durability of the aluminum, depending on the requirements of the final product. Every adjustment is carefully calculated to meet strict industrial standards. After melting, the aluminum is slowly cooled and cast into large, solid forms, often called slabs or ingots. These massive blocks represent a transition point between raw material and precision manufacturing. Once cooled, they are transferred to rolling facilities for further processing. In the rolling stage, the aluminum slabs pass through powerful rollers that gradually reduce their thickness. With each pass, the metal becomes thinner, smoother, and more uniform. This process transforms solid aluminum into long, continuous sheets that are perfectly suited for high-speed can production. By the end of this stage, the aluminum has been transformed from raw or recycled material into carefully engineered sheets. These sheets provide the foundation for the next phase of manufacturing, where speed, automation, and precision shaping define the production of aluminum cans. After the aluminum sheets are prepared, the production process shifts from material preparation to high-speed shaping. This is where flat metal is transformed into the familiar cylindrical shape of an aluminum can. The aluminum sheets are fed into automated forming machines where circular blanks are punched out at extremely high speed. Each blank represents the base of a future can. These blanks are then transferred into drawing presses where they are gradually shaped into shallow cups. In the next stage, the cups pass through a process known as drawing and ironing. During this process, the metal is stretched upward while the walls become thinner and more uniform. This step requires precise control, as the aluminum must be shaped without tearing or weakening the structure. The drawing and ironing process happens in rapid succession. Modern production lines can form thousands of cans every minute, with machines operating in perfect synchronization. Despite this speed, each movement is carefully controlled to maintain consistent dimensions and wall thickness. As the can body becomes taller, its strength is preserved through the distribution of material. The base remains thicker to withstand internal pressure, while the walls are optimized to be as thin and lightweight as possible. This balance allows aluminum cans to be strong, efficient, and easy to transport. Throughout this stage, sensors continuously monitor shape, thickness, and alignment. Any cans that do not meet exact specifications are automatically removed from the production line. This ensures that only uniform and structurally sound cans continue to the next phase. By the end of this process, the aluminum has been fully transformed. What began as a flat sheet of metal is now a precisely engineered container, ready for finishing, coating, and printing. Once the basic shape of the aluminum can is complete, the production process moves into the finishing stage. At this point, the cans already resemble their final form, but several critical steps are still required before they are ready for use. The first step is trimming. During shaping, slight variations in height can occur. High-precision cutting tools trim the top edge of each can to ensure a perfectly uniform height. This step is essential, as even small differences can cause problems during filling and sealing later on. After trimming, the cans are thoroughly cleaned. During forming, lubricants and residues are used to reduce friction and protect the metal. These substances must be completely removed before any coatings are applied. The cans pass through multiple washing stages using water, heat, and cleaning solutions. Once cleaned, the cans move to the internal coating process. A thin, protective layer is applied to the inside of each can. This coating prevents the aluminum from reacting with the beverage and helps preserve taste, safety, and shelf life. The coating is applied evenly and with extreme precision. Afterward, the cans travel through large industrial ovens where heat cures and hardens the lining. This step ensures the coating bonds securely to the metal surface and remains stable over time. Throughout this stage, automated systems monitor cleanliness, coating thickness, and curing temperature. Any cans that fail to meet strict quality standards are automatically removed and recycled. By the end of this process, the cans are clean, protected, and structurally complete. They are now ready for the final stages of production, where appearance, branding, and quality control take center stage. After the internal coating process is complete, the aluminum cans enter the final stages of production. At this point, the focus shifts from structural integrity to appearance, consistency, and quality assurance. High-speed printing systems apply detailed graphics, logos, and text directly onto the aluminum surface. These printers are capable of decorating thousands of cans per minute while maintaining precise color accuracy and alignment. The printed cans then pass through drying systems that permanently bond the design to the metal. Once printing is complete, the cans undergo comprehensive quality control. Automated inspection systems check for shape accuracy, surface defects, and structural strength. Pressure tests and visual inspections ensure that each can meets strict safety and performance standards. Cans that fail any part of the inspection process are automatically removed from the production line. Rather than being discarded, these cans are sent back into the recycling system. Because aluminum can be recycled repeatedly with minimal energy loss, this process significantly reduces waste. Recycling plays a critical role in the efficiency of aluminum can production. Using recycled aluminum requires far less energy than producing new metal, helping lower emissions and conserve resources. This closed-loop system allows aluminum cans to remain one of the most sustainable packaging solutions available. From raw material to finished product, aluminum can manufacturing is defined by speed, precision, and continuous optimization. What appears to be a simple container is the result of advanced engineering and highly automated industrial systems that operate at massive scale.